So, welcome to this screencast on gravity. This video is mostly made for teacher information, so some of the background may be too advanced for your students. But let's go and get started. So let's talk about gravity. So the first thing that most people think about when they think about gravity is just the simple apple falling from the tree. It hit Isaac Newton in the head. He wondered why. So there's two questions that tend to pop up in students' minds when you start talking about gravity. The first question is what keeps us from floating off into space if we jump off the ground on planet Earth, of course. And the second question is, why does something I drop fall to the ground? So we're going to kind of be discussing those two questions and keeping it as relevant as we can for you discussing gravity. So first thing you got to consider is, what is gravity? The law of gravitation states that any two objects exert an attractive force on each other. Okay, well first, if you break it down, you got to understand that any two objects mean any two objects. We're not talking about size, we're not talking about mass at this moment. We're just talking about two distinct separate objects. And then where it says exert an attractive force, an attractive means like a north and a south pole magnet. They're going to attract each other. So this video will give you some basic background for teacher information on gravity. Enjoy!
We're all familiar with gravity as the reason objects fall, but there's much, much more to gravity than that. Gravity is a long-range attractive force between all objects with mass. It's what keeps us from falling off the Earth, it's what keeps the Earth in orbit around the Sun, and it's what caused the Sun itself to form 4.5 billion years ago. It's amazing to think that every massive object attracts every other in the universe. That means that your dog, the Earth, and a black hole in the Andromeda Galaxy 2.5 million light-years away are all gravitationally attracted to you, and you to them. In the 17th century, Isaac Newton discovered that the strength of the gravitational force decreases by the square of the distance between two objects. So if you're twice as far away, gravity is only 1/4 as strong. He also discovered that the strength of gravity is proportional to the mass of the objects in question. The more massive an object, the stronger the gravitational force. That's why we can all feel the Earth pulling on us, but don't really notice the pull of the moon. It's smaller and farther away. The moon's gravity is strong enough to cause the tides, though. And when I said earlier that gravity is an attraction between objects with mass, I lied. I meant objects with energy. Because in addition to massive objects, gravity also attracts light and other massless but energetic particles, so that a photon of light can be bent slightly passing the sun, or trapped completely by a black hole. Now do you understand the gravity of the situation?
Alright, so now let's talk about what gravity depends on. Gravity basically depends on two things, two variables. The first is mass. In other words, how much matter makes up that object, and then the distance from the object. So from object A to object B, the distance between those two. So now let's discuss the mass and the distance parts of gravity. So the first thing is, the larger the object is, the more gravity it creates. In this example, in this picture, the sun is obviously the largest object in the picture, therefore it creates the most gravitational pull. The Earth is the second largest, and it creates a strong gravitational pull with the sun, but not as much as the sun, given the fact that the Earth is smaller. And then we have our moon that is very close to Earth, and its mass is much smaller than the Earth, so it creates a lesser gravitational pull than the Earth does. And then the other part of gravity is the distance, closer versus further away. When two objects are very close, they have a very strong gravitational pull. Example of this would be the Earth and the moon. The moon is close enough to the Earth to control the tides on Earth. So you have your neap and your spring tides. And then as far as further away goes, the sun causes a gravitational pull with the Earth as well as every other planet in our solar system, keeping those planets in their orbit. So one major question that students have is, does gravity have anything to do with our solar system? And I guess the answer would be that gravity is a force that governs the motion of our solar system. That these planets orbit around our sun in very natural orbits that are governed by the gravity from the sun. So Mercury's in its own orbit, Venus, Earth, Mars, Jupiter, and so on. That's all, folks.